Let's begin by taking a look at a simple example of adding two vectors that are perpendicular to each other. Let's say SpongeBob walks 30 meters west to visit his friend Patrick, and then walks 100 meters south to get to the Krusty Krab. What would be the magnitude and direction of SpongeBob's total displacement in this case? I'll begin by drawing a vector to represent each of SpongeBob's displacements. He begins by walking 30 meters west, so I'll show an arrow starting from SpongeBob, going towards Patrick, and that'll be 30 meters, and that is west. And then I'll show another arrow going from Patrick to the Krusty Krab, and that is 100 meters, that's the magnitude, and the direction here is south. And when I'm asked to solve for the magnitude and direction of his total displacement, I'll begin by drawing the resultant vector. And so again, to draw the resultant vector, I start from the very beginning, so the tail of the first vector to the head of the last vector, and that would look like this. Right, so this is my resultant vector. This is my total displacement. And the magnitude and direction can both be obtained using, in this case, more simple methods than we'll see in a moment when we have two vectors that are not perpendicular. And so because these form a right triangle, essentially it becomes pretty straightforward to solve. If we were to call this first vector A, the second vector B, and the resultant vector C, then we can use the Pythagorean theorem to calculate the length or the magnitude of the resultant vector. So we can say a squared plus b squared would be equal to c squared, right? That's the Pythagorean theorem, which means that c, our resultant vector, would be the square root of a squared plus b squared. And so because I know outright what a and b are, I can go ahead and plug those in. That would be 30 meters squared plus 100 meters squared. And that will give me a resultant vector length of 104.4 meters. So that's the magnitude, but what about the direction? Well, when I say direction, I'm essentially solving for this theta value right here. So the angle below the horizontal, and we'll use our compass directions to label this in a moment, but essentially the angle from which SpongeBob leaves his house towards the Krusty Krab. So what would this direction be? Well, I can use inverse tangent. Now that I've solved for the resultant vector, I can actually use any of my trigonometric functions. But I know, right, that tangent of theta is equal to the 100 meters. That would be my opposite side. So that would be opposite. And then that would be divided by my adjacent, which would be 30 meters, right? Because A is the adjacent angle, or the adjacent side. And that would give me then some expression. So to find theta, I actually have to do tangent inverse of both sides. So I'll go ahead and do tangent inverse of this. So you'll see this as tangent to the -1. You'll also maybe see this sometimes as a arctangent on your calculator, either one. And then that will be tangent inverse of all this. So that means that theta is tangent inverse of 100 over 30. And when I put this into my calculator, I will get, make sure you're in degrees mode for everything we do, you'll get a degrees of 73.3 degrees. And so I see here this angle is actually 73.3 degrees. Now, how would I report this using my compass directions? Well, if I show the resultant vector like so, right, this is my resultant vector, I know that this angle, right here, this theta is 73.3 degrees. Well, the nearest compass directions would be if I go ahead and just show I'll draw in a reference axis here. This is north, east, south, and west, right? So I've just drawn that in as a reference point. That would mean that this degrees, right, is going towards south from west. So I would report that as south of west. So please make sure that you feel comfortable reporting this direction. If you need to review this, please look at my previous video. So that would mean then SpongeBob's total displacement is 104.4 meters at 73.3 degrees south of west. So this is an example of doing vector addition for two vectors that are either perfectly horizontal or vertical that form a right triangle. And in this case, we can use the Pythagorean theorem and tangent inverse to solve for the both magnitude and direction. In the next video, I'll show you how to do a similar process when we have two vectors that are not perpendicular, meaning that one of them or both of them are at an angle to each other.